This is the last session that we'll be holding this year in our Diverse Brains initiative. As I mentioned at the beginning of the year, this is something obviously that's not just this year. We want to maintain this effort over the next many years. And I look forward to hearing from you guys in terms of what you thought about what we did this year. At our upcoming FBI retreat on May 20, please put it down and join us. We'll be having further discussions, taking stock of what we've done during the year, and then looking forward to things that we should be doing next year. So please don't be bashful and send comments along. So it really is a great pleasure to introduce Liz, who's been a friend for many, many years. This is not the main focus of Liz's lab, and we'll have her come back and talk about her work on traumatic stress and other factors. But it's a pleasure, and we appreciate her taking the time to do this. Liz, thank you.
Thanks. So I think it's terrific, this series you guys are doing, and I would love to see that something similar to NYU. I'm glad I could contribute. As Eric mentioned, this is not my main focus, but it has been a consistent area of research that I've worked on. So I will sort of show you, it's been sort of on the sidelines, and I do this because it links to my primary research, I think, in some important ways. So hopefully that will become clear. I'm going to talk about race in the brain. In particular, I'm going to talk about black-white race differences in the United States. So in the U.S., as all of you know, there's been a marked decrease in the endorsement of negative race attitudes over the last century. If you were in the 30s, somebody might not have any qualms about expressing negative race attitudes. But if you ask people today, almost everybody expresses egalitarian views about race. But in spite of this, as all of you know, the evidence of race bias persists. Most recently, we've seen a number of high-profile cases in the media. For instance, Trayvon Martin, a boy who was out with some Skittles in his pocket, was killed. Here in New York, Eric Garner. In Ferguson, Michael Brown. And this has sort of prompted this new movement called Black Lives Matter. This also has led to discussions of this idea of systemic racism, and that's probably most apparent in our legal system. So I'm just going to give you some statistics from our legal system. In the U.S., black males are 6 times more likely to be incarcerated than white males. The likelihood of jail time is higher for black males for equal offenses. The Hispanic and black males receive longer sentences than white males for equivalent crimes. Inmates, and this is a work of Jennifer Eberhard, it's very interesting, inmates with more Afrocentric features, whether or not they're black or white, will receive harsher sentences than those with less Afrocentric features. And here's just a chart showing you the likelihood of receiving the death penalty. And only when you get to the most serious crimes, or the least serious, are you less likely to receive the death penalty if you're black. For the medium crimes, you're much more likely to receive the death penalty if you're black. And so there's abundant evidence that unintended race bias influences legal decisions in the United States. Some of the political candidates you're hearing from now always sort of hark back to socioeconomic differences as if this is a reason for this, but recent investigations show that's not the case. So if you're a wealthy black child, you're a black kid, you're more likely to go to prison than a less wealthy white kid. So in here, we're just looking down here at the decile of wealth and race and the likelihood that you're going to be incarcerated at some point. Now, these are sort of dramatic examples, and most of you probably aren't involved in the legal system. Probably the type of bias you might feel yourselves are much more akin to something like we saw with Hurricane Katrina. So here is an example of 2 articles that came out in the same day around the time of Hurricane Katrina. Here we see a young black man who looted a grocery store when he was trying to get supplies. And here we see this nice white couple who were lucky enough to find bread and soda from a grocery store. Maybe they also picked up, the Sunday New York Times, who knows, right? But this is really the subtlety of this type of bias that we talk about. Not so much, for obviously there's issues with legal decisions and things like that. But those of you who are not in the legal system have much more of these experiences of very subtle differences in how we attribute behavior, how we're seen by others, and how we feel in the circumstance, whether we're standing out or not. And we call these subtle differences implicit bias. So I first want to just make a point. So how is it the case that we have now come to, in general, believe egalitarian views? And you could say people are lying when they express this, but I think most of the time they're not lying. This is actually what people's beliefs and intentions are. So how do we make this difference we have between our beliefs and our perceptions and our actions? And I just want to give you an example from perception that kind of makes the point. So which table is longer? Anybody want to answer? Class participation time here? The left one? Okay. Actually, they're the same size. So now this, if you take an intro psychology class, you'll see something like this, right? Just a classic perceptual illusions. We have decades of experience learning about things like linear perspective. These things help us take 2D images, transform them into 3D models of the world. And we wouldn't want to undo this type of learning, right? It helps us get around. But I'm going to argue that cultural learning about stereotypes can affect our perceptions and responses to others, even when we're not aware of its influence. So if I went back to these tables, now they're the same size. You still can't see them as the same size, right? So you have a knowledge here that is going to be different from your perception. And I would make the argument that cultural learning does something similar. It takes this kid here that may, in a hoodie looking like he may want some Skittles, and whereas this kid may look like he's dangerous to you. And so the argument that social psychologists would make is that this cultural learning, even when we're aware that it's wrong, these stereotypes that are out there can affect our behavior and our perceptions, even when we don't intend it to do so. And I think you've learned already in this seminar. I heard you had a session on implicit bias, so I don't have to tell you much about this. And I won't make you do the test. I'll just show you. But social psychologists define two types of attitudes. Explicit attitudes, these are consciously, explicitly expressed. They're thought to reflect your beliefs and intentions. And implicit attitudes, these are expressed through our responses and actions without necessarily our conscious effort or control. And these may reflect affective or emotional associations that are linked to cultural stereotypes. So just to give you an outline of my talk for today, I'm going to talk about sort of how I came to this science, where we sort of started to build a neural model of implicit race attitudes. And I would say it's a sparse neural model, but it's a beginning. And then I'm going to talk about research we've looked at where we try to take advantage of our understanding of the neural circuitry of implicit race bias to enhance our understanding of race interactions. And finally, at the end, I want to just talk a little bit about how we might change race bias in the brain and behavior. And here's some encouraging news and also some promissory notes going forward, but at least the perspective we're taking on it in my laboratory. So how did I come to this? I think Eric mentioned this is not my thing, right? I was trained in cognitive psychology and then retrained in neuroscience. I was studying emotion and learning in the brain, and that was my area, that still is today my primary area of research. But I came to this through a back door of being interested in emotional learning in the brain. And I'm just going to give you an example. So here's a sort of typical emotional learning paradigm that one would use in the laboratory, and we do this all the time in my lab. This is a slide I borrowed from my longtime collaborator, Joe Ledoux, and it's just Pavlovian threat conditioning. You take a tone, you pair it with an aversive event. After a few pairings, the tone itself comes to elicit a response consistent with fear, such as freezing. We know from work of people like Joe Ledoux, Mike Davis, Bruce Kapp, and others, that the amygdala, here in red, 3 different views. The ones I'll show you will look sort of like the ones up on the right. That the amygdala is important for the acquisition, storage, and expression of these simple associations, just associations by pairing. You don't have to do anything. If you do similar things in humans, we take a neutral stimulus, a blue square, pair it with a mild shock to the wrist. After a few pairings, the blue square itself comes to elicit a range of responses such as sweating, autonomic arousal, things consistent with a fear response. So when I was looking at emotional learning in the brain, I was interested in these models and extending them to humans. So I did that very simple type of experiment where I paired a blue square with a shock. And I found, not surprisingly, robust activation of the amygdala. This is a very early brain imaging study. And if I looked at patients with amygdala damage, here what I see on the bottom, on the top is a healthy participant, and this is the skin conductance response. This is sort of an indication of autonomic arousal. And when the patient, when a normal person gets a shock and the patient with amygdala damage, they show an increase in arousal, autonomic arousal. For a person without amygdala damage, a person with an amygdala, I should say, they also show this increase when they see a blue square that predicts a shock. The patient with amygdala damage does not. This is just telling us that the human amygdala is necessary for this physical expression of a learned aversive response in threat conditioning. So what does this have to do with race? So here is this patient with amygdala damage. We showed her her data, sort of the real data, not the cartoon version of the data, where she failed to show this anticipatory response. And this is what she said.
I notice that there's anything odd about just a normal lifestyle, life threats. My fear element seems to be, to me, in my head, normal. I've never noticed anything odd.
And how do you feel seeing these results? I mean, how does that make you?
I'm dead. I think that it's probably absolutely correct. I know I don't sweat. I knew that there was an anticipation that the blue square was going to, at some particular point in time, bring on one of the volt shocks. But even though I knew that, and I knew that from the very beginning, except for the very first one where I was surprised, I really don't think that I mean, I knew it was going to happen, but that was my response. I knew it was going to happen. I accepted that it was going to happen. So I learned from the very beginning, it's going to happen. Blue shock. Happened. I turned out to be right. It happened.
So I think as she dramatically demonstrates, she has this perfect awareness of the relationship between this blue square and this shock. What she fails to have is sort of the ability to show me that learning implicitly. And so this was actually filmed at my lab when I was at Yale University. That was Kevin Labar behind her, who was a graduate student at the time who worked on these projects. He's now a professor at Duke. But also at Yale University at the time was this woman. This is Mahzarin Banaji. Mahzarin is also interested in emotion and learning, but from the social perspective. And she was doing this groundbreaking research at the time where she was looking at this difference between implicit and explicit attitudes. Where some of the earliest research showing that they diverge, that your implicit attitudes don't always coincide with your explicit attitudes. You can have egalitarian views, yet very sort of pro-white implicit attitudes. And it seemed to us there was this similarity between what I was seeing in this patient with amygdala damage and what Mahzarin was seeing with this dissociation between the knowledge of what, the beliefs, the intentions of what I want to be true in the world and how I think I approach it in my explicit attitudes, but your implicit expression of that learning. And so we did this very simple experiment, again, very early days of brain imaging, asking the question, does the amygdala play a role in the expression of implicit race bias? So we did a study. This was with Yale undergraduates. They were white Yale undergraduates. They viewed unfamiliar black and white male faces. And during the actual scanning session, they weren't told this was a study about race. They just simply were asked to press a button if a face was repeated. After the scanning session, we gave them 3 different assessments of race attitudes. Explicit race attitudes using a standard scale, so here, tell me what you believe about differences between the races. Implicit race attitudes with the implicit association test. I think you know about that, but I'll show you an example in a second. And because I was studying, physiological responses in my threat conditioning procedures, we also did a physiological assessment of an affective response. Essentially what we did was we showed people black and white faces, and we played a loud noise. It wasn't loud enough, so we has to blink. So anyways, if you hear a loud noise, when you're looking at something that's negative, you're going to blink harder. This is getting your startle reflex to go. The classic idea here is if you're walking down the street late at night and no one's around and you're a little nervous and you hear a car backfall, you jump even more, right, than if that happened in the middle of the day. And so we showed pictures of black and white faces, played a loud noise, measured the startle reflex by measuring how hard they blinked their eyes. So the implicit association test, we're going to talk about this a lot. Is everybody here familiar with it? Yes? No? Okay. So I'm going to run you through this. If you were my introduction to psychology class, I'd make you do this, but I'll spare you. But you can sort of mentally try to do it. The way the implicit association test works is it measures differences in reaction time when you have to pair different types of concepts. Okay, and so the notion if it takes you longer to pair 2 concepts together, there's some sort of interference of sorts. And so the way this would work in this particular experiment was you would see coming up on the screen, and they're going to appear here, 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 all the way around, faster than you could actually respond. A face that's either a black face or a white face, or a word that means something good or something bad. So what I would have you do if you were actually doing this, I'd have you say tap your left thigh if it was white face or a word that meant something bad, and your right thigh if it was a black face or a word that means something good, and I'd have you go through all of the stimuli, and I would time you. So if I did it like this, I'm just going to tell you what I find. If you, in this case, so now you're pairing white with bad and black with good. Half the trials look like that, and half the trials look like this. Here, your left thigh, if it's a black face or a word that means something bad. Right thigh, if it's a white face or a word that means something good. And again, if I were to do this to my introduction to psychology class, which is mixed race but predominantly white, I would find about a 2-second difference in how long it took them to do the 2 pairings. This is a classic finding for white Americans. So white Americans take longer to pair black with good and white with bad than the opposite. And it doesn't matter which order you go in. It's not a practice effect. If you're African American in the United States, as a group, you show no bias. Having said that, you're just going to show a lot more variability. So some African Americans show a pro-white bias, some show a pro-black bias. In New Haven, where we did these studies, the Yale undergraduates who were black would show a pro-white bias. The Yale community, the New Haven community, that were not at Yale would show a pro-black bias. So there's just more variability if you're African American. And it may have something to do with your cultural learning, your surroundings and things like that. If you're interested in this, there's, and you probably heard about this on your discussion of implicit bias, Mahzarin Banaji and her former student Brian Nosak have a website that you can go to and try these different tests. They've had, over 1 million people take these tests, and they're building a large database to see for trends throughout the country. And it's not, you can use this test not just for race bias, for gender bias, age bias, all sorts of other types of assessments. So back to our study. So what did we find with our white Yale undergraduates? Not surprisingly, it took longer to respond when black was paired with good and white with bad than the opposite. When I looked at how much they blinked in the presence, when they heard a loud noise and they were viewing a white or a black face, they blinked harder. They were startled more when they were viewing a black face than a white face. These are my 2 implicit measures of race attitudes. But when I looked for relations between those responses and amygdala-bold responses, I saw the implicit association test and eye blink startle showed greater amygdala-bold responses the higher your implicit bias on those two tests. Now, this was a very early study of brain imaging. It was a 1.5 Tesla magnet, big voxels, any of you who do brain imaging. We didn't actually see an overall difference between when the participants saw black or white male faces. Other people have replicated the study and have seen that with more sensitive scanners. But we did see this relationship between your implicit bias and how much amygdala activation you you showed. And there was no relationship with our explicit measure of race attitudes. This is just showing you the same thing. Here I'm just saying show me regions of the brain that show greater bold differential responses to black versus white faces that correlate with your implicit bias. And again, I see amygdala activation for the implicit association test and startle eye blink. So this told us that amygdala activation correlates with the strength of implicit race bias, consistent with the idea that maybe it has something to do with the implicit expression of these associations, but not your explicit beliefs. One of the things we know about the amygdala is that, from other studies, is that it can respond very quickly to stimuli in the environment that someone might think is threatening. So Will Cunningham, who was an author on our first paper, did a follow-up study, and he said, well, what happens if I show you the faces so quickly that you're unable to detect them? So again, subliminal presentation of the faces. And so what he did, he showed black and white male faces. He had these funny-looking things coming before or after to mask these stimuli when they were presented very quickly. So sometimes the faces were on for 30 milliseconds. And if it was that quick with these masked stimuli, people could not perceive them. Sometimes the faces were on for about a half a second, and then people could perceive them just fine. What Will found, interestingly, when he looked at the amygdala, was again replicating our earlier study, greater amygdala activation to black versus white faces in white American participants. But if you look here, the dotted lines are the subliminal presentation of the faces. The solid lines are the supraliminal, where they can see. You actually get stronger amygdala activation when you are unable to perceive seeing the faces. So the amygdala is known to be a region that detects threat very early in stimulus processing, but it also can be inhibited by other brain regions if it's determined that that threat is not a real threat. And so what we're seeing is looking like some inhibition of the amygdala to black versus white faces when you are aware of their presentation. And again, Will also found that these differences correlated with implicit bias as measured by the implicit association test. So what regions showed greater activity now when you are aware of seeing the faces versus not? There were two. One is the dorsolateral prefrontal cortex, and one is the anterior cingulate. And so we had to ask the question. So again, these regions showed greater activity when you were aware of seeing black versus white faces versus not. So we had to ask the question, could these regions play a role in inhibiting the amygdala response when you are aware of the presentation of the faces? And one of the things, this is a study by Jen Richardson, what she had people do was she had people have an interracial, these were white Americans again, this was at Dartmouth. She had them have an interracial interaction. Then she put them in the scanner. She showed them black and white male faces. And she showed, to the extent that you show a high implicit pro-white bias, you show greater activation of the anterior cingulate and the dorsolateral prefrontal cortex when you're now viewing black and white male faces. So let me just put this all together because this is sort of our beginning of our neural model. So what do we know about these regions from other studies? So I mentioned the amygdala as a brain region we know is important in this learning these associations through pairings, these negative associations through pairings. It can pick up on threats in the environment very quickly. The anterior cingulate is a region that's often implicated in conflict detection. The dorsolateral prefrontal cortex we know is a region that plays a role in the cognitive control of emotion. Now, in the context of these studies, in particular looking at Jen Richardson's works, we would suggest that perhaps the anterior cingulate detects a need for regulation of implicit attitudes. So you If you know, you have this association, it may not be your intention or your belief, but nevertheless it's there. So the anterior cingulate may detect a conflict between your egalitarian beliefs, your explicit attitudes, and your implicit attitudes. The dorsolateral prefrontal cortex, we know, plays a role in the cognitive control of emotion. And in this case, we think it might regulate implicit attitudes in a manner consistent with explicit attitudes. So this would suggest that a neural model is something like this. You encounter somebody of another race. Your amygdala pays attention to socially relevant stimuli. In this case, if you might perceive a threat association of sorts, that may be inconsistent with what your beliefs are about the different races, then your anterior cingulate might detect that conflict. Your dorsolateral prefrontal cortex then may play a role in essentially inhibiting or damping down this amygdala response. This suggests that, we at times may unconsciously attempt to regulate the expression of our implicit attitudes to be in line with our egalitarian goals with more or less success. So Jen Richardson, who's now at Yale, has also done a lot of work showing that if you do things like cognitively tax people, they'll show more implicit bias, right? Especially when they have an interracial interaction. So in other words, again, they are not, they're not consciously trying to change their attitudes, but they notice perhaps that they have some implicit bias, and they're trying to control it in some way, and they can't do that if they're cognitively taxed or if they're stressed. All right. So I've given you sort of how we are building up a neural model of implicit attitudes, and now what I want to do is ask the question, can we take advantage of our understanding of the neural basis of implicit attitudes to enhance our understanding of race interactions? So I'm going to talk first about how we learn from others, and then how we make decisions about others. So one of the things that we knew from our studies of the amygdala and race is that, one, we see greater amygdala activation to black versus white faces, particularly white Americans. Two, that's even stronger when these faces are presented subliminally. And another class of stimuli that shows the same pattern of amygdala responses is what we call biologically prepared stimuli. It's been argued that there are some stimuli in the environment that are prepared by evolution so that when we learn something negative about them, those stimuli, those things in the environment, we actually then hold on to that negative association longer. It's harder to get rid of. And that's because through evolution, they're natural threats. And the research on prepared learning has primarily looked at things like spiders and snakes and using control stimuli of things like birds and butterflies. So the argument is spiders and snakes are more likely to be dangerous to your survival. They can be poisonous. And so therefore, you have a bad interaction with a spider or a snake. You form this association with danger and that stimulus, and it's harder to get rid of. We wanted to ask the question, and so let me just run you through this study. So this is a classic study looking at prepared and unprepared learning. So here we had 4 different stimuli participants saw. For half the subjects, they got, for one of these stimuli, these prepared stimuli, they got a shock to it. This was our control stimulus, our baseline. For the other half, for these non-prepared stimuli, unprepared stimuli, they got a shock. The other one was our control baseline stimulus. So here I'm looking at skin conductance, just like I showed you earlier, after these things are paired. So here is when the, let's say, snake is paired with the shock. The spider is not. I've subtracted the skin conductance response to the 2, right? So anything increasing here is a stronger response to the stimulus paired with shock versus not. This is for the fear-relevant stimuli. Okay, that's the spiders and snakes. Here's the birds and butterflies. And what we see is that participants can acquire a fear response to both of these classes of stimuli. But now I've stopped presenting the shocks. Okay, and this is called extinction. Right, so Pavlov described extinction. You just stop giving the reinforcer. Eventually, the response should go away. But what you see is you get less extinction for the fear-relevant stimuli. So it's almost as if Once you've learned this thing is dangerous, you hold on to that learning longer. So we want to ask the question, given that prepared stimuli look like other race faces in their pattern of amygdala response, do other race faces look like prepared stimuli in threat learning? So we did a simple study like this. This study we did both with black and white participants, and this was done at NYU. So they saw 2 white faces. One was paired with shock, the other was our baseline. 2 black faces, one was paired with shock, the other was our baseline. And this is what we found. So again, here's where we see the 2 paired. You see good acquisition both for these threat responses, this autonomic response, both to a racial outgroup member and a racial in-group member, somewhat stronger for the racial outgroup. But again, you hold on to that learning longer. It doesn't go away now that you stop pairing the stimulus with a shock. Here I'm breaking it down. These are our white participants and our black participants. And what you can see is we see this for other race faces. It doesn't matter if you're black or white. For your other race face, when that's paired with a shock, you hold on to that learning longer, even when there's no longer a threat there. What's interesting, if you look at these graphs, it looks a little bit like the black subjects maybe aren't showing the effect quite as strong, especially in the acquisition, right? But we looked for a number of variables that might predict the strength of this effect. We looked at IAT. We looked at contact measures, a whole range of them. We looked at whether, how many friends and acquaintances do you have of other races. We looked at whether you dated outside your race. Now, I should tell you, all of those things are correlated. But if you dated outside your race, you completely eliminated this effect. So if I now take out, and about half of our black American participants had dated outside their race, and about a quarter of our white American participants. The difference, I don't know if it's just due to opportunity by virtue of being a minority, you have more exposure, or something else, who knows. But if we take out those participants, we see equal effects for both the black and white participants. Again, with the other race face. So what does this tell us? So, I asked the question, can we take advantage of our understanding of the neural circuitry of implicit race bias to enhance our understanding of race interactions? What this is telling me, if you're looking at other race individuals, it's harder for you now to sort of unlearn, to change your associations if it's a negative association with new experience. In other words, there may be this preparedness to associate negative outcomes with outgroup members, and these negative associations may be harder to change with new information. And contact with others may alter your perceptions of in-group, we think, and mediate this effect. There's really no stronger way to change your in-group than to mate with somebody not in your race, right? It changes who you think is your in-group. Now, if we believe the evolutionary story of prepared learning, and that has something to do with this effect, and I should say an evolutionary psychologist followed up on these effects and showed that it's specific to male faces, not female faces, and his argument would be males were more of a natural threat through evolution. If we believe that, we think then what this tells us, this is not an effect due to race, right? We didn't evolve in multiracial groups, but we did evolve in social groups. We evolved in tribes. We evolved to have people that were in our group and people that were not, and people that were not in our group were more of a natural threat through evolution. So this tells us it's not about race. In this society, it might be about race. It's one of the primary ways we divide up our social groups. But other societies, it's not about race. It's religion, other factors that become a primary way that we divide ourselves up. So I want to now move on. I've talked a little bit about learning about others. I want to talk about how we make decisions about others and how we can be inspired by the brain science to understand this a little bit better. One of the first things we looked at, so again, this is again kind of looking at the similarity between what we see with implicit bias and what we see with other judgments. And one thing we know, again, with stronger amygdala activation for higher pro-white implicit bias if you're white American, you also see stronger amygdala activation to faces you think are untrustworthy. So this led to the question, is race bias predictive of economic decisions to trust? So we did a classic behavioral economic game called the trust game. So here if you're my participant, you come into the lab, you see a series of screens like this. I ask you the question, how much would you like to share with this person? You know that you're playing this game. I fully explained it to you ahead of time, so here I'm going to walk you through it. You see this partner. You ask how much you want to share. You have $10. You can share 2, 4, 6, 8, 10. If you don't share any money, you keep the $10. If you share, say, $7, now you have $3 left. But your partner, we quadruple that. Your partner gets $28. Now your partner has a choice. Your partner can either choose to keep all $28, so now you're left with $3 and they have $28, or your partner can choose to share the earnings with you, so essentially rewarding you for your trust. If that's the case, now you have $17 and your partner has $14. So you see a series of faces like this. You see about 100 black faces, 100 white faces, about, I think it was 60-something other race faces. And you make this judgment over and over again, and you're actually paid the outcome of a couple of your decisions. So there are consequences. And what we see is the extent to which you have a disparity in your offer, the amount of money you give to black versus white faces correlates with your implicit race bias. So here's what we call your IITD score. People on this side have a stronger pro-white bias. People on this side have a stronger pro-black bias. I should say we had our participants were multiracial. By having multiracial participants, we get a much broader range of implicit bias scores. So we didn't select based on race. Here is somebody with a high pro-white bias. Here is the amount of times they made offers to different people of different races. So here is the amount of times they made offers to black participants of $2, $4, $6, $8, $10. And here's for white partners, I should say. So as you can see, they gave more money to white partners than black partners. Here's somebody with a slight pro-white bias, and you can see this is skewed towards higher pro-white biases and pro-black, but somebody with a slight pro-black bias. You can see they gave slightly more money to black partners than white partners. So this suggests to us in economic games, implicit race bias is related to decisions to trust, right? The higher the pro-white bias, the more you invest with white partners relative to black partners. Now, one thing about this game is, there may be a cost of not trusting, right? But you don't really know, because you don't really know in advance who's trustworthy and who's not. So we want to ask the question, if it's really clear that there's a cost to you, would you still show bias in your decision making? So to do that, will race bias in economic decisions persist if there's a personal cost? So to do that, we did the ultimatum game, another standard behavioral economics game. So in this game, they saw, again, 60 black partners, 60 white partners, and 40 other partners. You saw a screen that looked something like this. Your partner always had $10. The partner had the opportunity to share some of that with you, right? Anywhere from $0 to $4. So you're always the responder. Now, as the responder, you can't do anything about what they offer you. You have one option. Your only option is to reject the offer. What happens if you reject the offer is that your partner gets nothing and you get nothing, right? So it's not rational to reject anything, right? You're just giving money away just because you're pissed or something, right? Yet, what economists have shown is that if it's a $10 pot, when someone offers you about $2, you're about 50-50 likely to reject. So you're willing to give up that $2 just to punish the other person for being, so unfair, right? Not rational, but nevertheless, that's what happens. So that's why our offers were all in the range of $0 to $4. It's right around that indifference point. So you're always the responder, again, looking at these two individuals, looking at this individual. And what we find is the acceptance rate. So again, here there were 60 white proposers, 60 black proposers. They gave identical offers, right? They all were numbers like this, so people couldn't really keep track, but they gave identical offers. People were more likely to accept unfair offers from white proposers than black proposers, even though it cost them money immediately. There was about a 5-cent difference, so if I were black, I'd have to pay you about 5 cents more to have you not reject my offer. And here IIT counts for some of the variance, not a ton. So even when there is a personal cost, people will pay more to punish unfair black versus white partners. And these are very subtle differences, but you can imagine over thousands of iterations, they actually become not so subtle. So one other type of decision I want to talk about, and this gets back to sort of the legal decisions, is what we call attribution decisions. And this is really related to decisions about the cause or attribution of behaviors. So I don't know how many of you have an intro psych, but something they talk about a lot in intro psych is a fundamental attribution error. So I'm going to walk you through what that is. So let's say you're driving in New York and this happens, some guy cuts you off and you're like, hey, what do you think about this guy? Anybody? Totally an asshole, right? Oops, we're recording, sorry. Okay, so you made an attribution about this person's disposition. He's an asshole, right? Or rude. You can just say rude, right? If you want, right? And this is actually what most of the time we do this, right? We most of the time assume it's something to do with that person's personality, who they are as a person, their disposition, and that's why they did it. They're a jerk. We call this the fundamental attribution error. We actually don't apply this to ourselves. For us, we're like, oh, but I was busy and I had to go somewhere. I'm usually a really nice person, right? But the point is, we tend to default to making dispositional attributions about the cause of other people's behavior. That is the fundamental attribution error, overweighing the dispositional explanations for behavior. You can imagine, that this person's rushed. Maybe they're, maybe this person's wife is pregnant and they're going to the hospital. Who knows, right? You can imagine, thinking about the fact that maybe the situation's causing them to do this. Well, psychologists have shown that this takes a little extra effort on our part, a little cognitive control. In fact, we've shown if you're stressed, you're more likely to make a dispositional attribution than a situational attribution, right? In part because stress, it's harder to get cognitive control on board. So we looked at this attribution bias to see is it different for black and white participants, or excuse me, black and white actors. You're always making the judgment. So here's what this study looked like. So Tom left the restaurant in a hurry without tipping the waitress. Why? Well, he's rude. Then you hear Tom's baby was screaming. So now you're asked, okay, why was this behavior caused because Tom's rude or because Tom was in a bad situation and Tom's not rude? Half the time Tom looked like this, the other half of the time Tom looked like this. Some of the behaviors were positive things, some of the behaviors were negative things. And this is what we found. So here, for the positive behaviors, this is whether you attribute it to the situation or the disposition, right? For the positive behaviors, whether you're looking at a black actor or a white actor, you're equally likely to say situation or disposition. For the negative behaviors, if you're looking at a black actor, you're more likely to say it was their disposition than for a white actor. When we looked at the amygdala response during this task, what we saw is it mirrored our attribution ratings, right? So in other words, we asked, so this suggests that perhaps amygdala bold activity is greater for negative behaviors by black versus white actors, and maybe that contributes somewhat to this bias and attribution rating. So in other words, do these culturally acquired amygdala-related threat associations contribute to attribution biases? When we looked for the relationship between IIT, whether you have a strong pro-white IIT or not, and the likelihood that you made situational or dispositional attributions, we found the stronger the pro-white implicit bias, the stronger the attribution bias. In other words, the more likely you were to say disposition than situation for negative actions by black actors. And if we looked in the dorsolateral prefrontal cortex, what we found is, to the extent if you have a pro-white bias, when you made situational attributions as opposed to dispositional attributions, you were more likely to show greater bold activity in the dorsolateral prefrontal cortex. So this suggests to us that maybe making a situational attribution with a black actor requires greater need to regulate implicit bias. So, attribution takes us back to what we were talking about earlier with legal decisions, right? Legal decisions require that you decide, if you know that something bad happened, was it intentional, was it not? Is the person, rude, or did the situation cause them to do that? And so we looked at legal decisions. So here we actually took something from court TV. It's a super long experiment where we have video from court TV and all these different things, a real case, where essentially there's a guy, Daniel Cote-Noir, I can't say his name right. He was a Marine vet. He was living in Boston area. He lived in a not very good neighborhood. There was a club nearby. The club shut down. People started to party sort of around his house. Someone threw a bottle or a rock or something and it hit his window. His kids were asleep. He ended up shooting into the crowd, right? And, the question is, did the situation cause him to do it, to shoot in the crowd, which of course was a crime, or was it because, he's a dangerous person? And half the time we just changed the picture of Daniel. Half the time Daniel looked like this. The other half the time Daniel looked like that. And what you find, and so here we measured implicit bias, that we didn't find a difference in guilt. Most people actually thought Daniel was guilty. I forget what happened in the actual case. But implicit bias predicted your sentence length, right? So in other words, if you had a higher pro-white bias, you would give the black Daniel a longer sentence than the white Daniel. So again, that's just coming back to, that's what attribution ratings are. So this part of the talk, I suggested that our decisions to trust, our decisions to punish, and our attributions about the cause of negative behaviors are influenced by implicit race attitudes. And again, in very subtle ways. Some of these things are quite small, but they aren't so small when you add them up over time and with repetition. So I want to now get to the last part of this talk, and it's going to be the shortest part of this talk, in part because I don't have a ton to say. But this challenge that all of this data and all this research suggests is we need to find ways to change implicit bias so that our actions and perceptions are in line with our beliefs and intentions. And there's been a lot of research looking at ways to change implicit bias. And the good news is this: there's several successful techniques. Okay, that most of them emphasize what we call counter-stereotype information. Right. So some exposure to somebody who doesn't fit the stereotype. So if you prime somebody with Obama for a short period of time, they'll show a little less implicit bias. But now all of you know Obama hasn't changed the discussion of race relations broadly in the United States, right? And part of the problem with these interventions is they tend to not last. So let me just walk you through a few that have looked at brain responses and changing brain responses. Evaluative conditioning, pairing black with good repeatedly, can change implicit bias. When you focus on the individual, so in other words, you may not, if you know somebody well, you may not see race as the first thing, or if you're focusing on that person, what their preferences are as an individual, you may not see race as the first thing that you respond to. So here, I should say, in our very first study, this was the first race study looking at race in the brain. I was quite nervous doing this study because I studied emotional learning and I knew it would get a lot of press. And so I actually insisted we do a second study where we put familiar and well-liked others, right? And it's interesting, I went back and looked at these. We had Bill Cosby up here. And I had to take that out, right? When we looked at familiar and well-liked others, we saw no consistent pattern of amygdala response, no correlation between amygdala and implicit race bias, right? So perhaps when you're seeing these individuals, race is not the first thing that jumps to mind. A study by Susan Fisk showed that, if I show you black and white faces, but I ask you to make a judgment either about a group, it doesn't have to be race, or about this individual, the amygdala responds to the black versus white faces only when I'm categorizing based on groups. So when I'm priming myself to think about this person in their social group. But when I'm thinking about the individual, I get less of a response. There's some very nice studies looking at how we change jury decisions. So now here, the defendant is a black American, and the jury's homogeneous, white, or mixed, you see different responses. So again, it seems to be priming from other individuals that you're interacting with may change the response. So prior to deliberation, what you find, this is the percent guilty votes if the jury's all white, if it's whites in a diverse group, or blacks in a diverse group, right? So the diversity of the juries can make a difference in part because you are primed by the partners in this decision. We did a study trying to get the brain basis for some of these sort of interventions, these counter-stereotype interventions. And we picked this. This was based on a meta-analysis by Lau at Harvard, working with Mazhar Banaji. He looked at all these interventions and said which ones are most effective. This was one of the most effective ones. So you had a story about a white assailant and a black rescuer. So again, priming, counter-stereotype priming. And you gave the participants strategies for response control and perspective taking when thinking about these things. Afterwards, you do an IIT. The control condition here, you read a story about the history of the toaster. Fascinating. So here's the Iit Pretest. So again, we have a pro-white bias on our Iit consistent with predominantly white American population. And after, here's our control manipulation. We see some decrease just due to practice times, but we essentially eliminate the bias after this intervention. We looked here at patients. So one question we had about this type of intervention, is it actually forcing you to control your attitudes more? So does it require the dorsal prefrontal cortex? Or is it sort of changing, at least temporarily, shifting this association that we think has something to do with the representation in the amygdala? So we looked at patients with amygdala damage and patients with dorsal prefrontal cortex damage. And this is what we found. So here in red is the patients with dorsal prefrontal cortex damage. Here in green, patients with amygdala damage. What we see is this bias, this counter-stereotype bias intervention is still effective at reducing the IIT in patients with dorsal prefrontal cortex damage, but not in patients with amygdala damage. So what we think we might be doing with these counter-stereotype interventions is sort of temporarily at least shifting the amygdala response. So this is the good news. So the good news is there's lots of things you can do to change these implicit bias responses. People are now starting to say, how does that link to changes in decisions? This is the bad news. The bad news is they don't last, right? So again, Lau's done a study recently showing that these reductions do not really last past a day or so. So it is a temporary shift in these associations. And if you think about it, this is just the classic problem of behavior change. You wouldn't want your behavior to so quickly change. For that perceptual learning, we need that perceptual learning to get around in the world, right? You wouldn't want your associations to change so quickly. The problem is, of course, then what do we do when we actually do want the behaviors to change quickly? And here, this is where I get back to my primary research question, which is threat conditioning, right? Looking at these associations. I showed you evidence, of extinction working to reduce this type of learning, right? The problem with extinction, which is really the basis for exposure therapy in the clinic, is these effects don't last past a day or so. You have spontaneous recovery, right? So these associations don't go away with extinction. They're simply inhibited, and that inhibition can fail. And so what we're trying to do in my lab now, and this is where our work in this line of research is going, is to, again, look at what we know about amygdala-dependent threat associations and techniques we can use to change them in a more persistent fashion. I'm not going to talk about these, but in my laboratory, we're trying to do things like target memory reconsolidation, We're looking at what we call novelty facilitated extinction, different ways to sort of amp up the learning signal to change those associations. Ways we might think about controllability that helps do a longer term change of those associations. And now the question we ask is, can these techniques that we're looking at to change threat associations be leveraged to help us change implicit bias when we want to, right? When we find that we actually have a high pro-white bias and that's not consistent with our beliefs or intentions. So what I suggest you in this last part of this talk is exposure to counter-stereotype information works, and there's lots of examples of this, but not for long. And again, going back to the basic science, we're now trying to leverage cognitive neuroscience studies of learning and emotion to aid in developing more lasting interventions. So I want to leave you with this idea, that sort of has driven this research. I mean, as I mentioned, I kind of fell into this research program through a collaboration with a colleague who I like and admire, and Mazrin and I have now been collaborating for close to 20 years. And it's not my main area of research. I'm the expert on sort of emotion learning in the brain. She's the expert on implicit bias. But we try to bring these things together because we don't think these are unrelated topics. And our hope is by combining these psychological and neuroscience approaches to the study of race attitudes, we can eventually develop better techniques to diminish the unintended consequences of implicit race attitudes on behavior and better align our actions with our goals. So with that, I need to thank the people that funded this research, all of my collaborators, again, especially Mazari, my longtime friend and collaborator, and all of you for your attention. Thank you.
So we do have a few minutes for questions.
Sorry for cursing in your talk.
Do the same, if I could. I did, actually.
Well, good. That makes me feel better. So this is fascinating, and I'm particularly fascinated by the last piece of data that you showed there, but I'm not sure that I understand it.
Which
so the one where you compare people with amygdala damage and people with dorsolateral
Yep.
prefrontal damage.
Yeah.
So am I right in thinking that people with amygdala damage then were able to form these biases?
Yes. So what we think is going on, and again, I don't know. So we showed that patients with amygdala damage actually have these associations, right? But they're not able to change them. So we think the amygdala is probably part of the story, but not the whole story, right? There's a lot of cultural learning and semantic knowledge that goes into this. But we weren't, these patients with amygdala damage failed to show this intervention of this counter-terrorist type, failed to show that it didn't work, right? But what is interesting and what you picked up on is that they actually do show this bias to start. And we actually published that a while ago as well after our brain imaging study. So it says that the amygdala is not solely driving the expression here. It is part of the network involved in it. And how the expression outside of the IIT differs for patients with amygdala damage versus not, we don't know. Now the amygdalas do not show enhanced potentiated startle amygdala patients to these stimuli. So it may be the case that the IIT is picking up on something, some aspect of this implicit bias, but not other aspects.
Yeah, I'm sorry, I gave my microphone away.
Okay.
But I was wondering if it was something to do with maybe the amygdala is more involved in the alteration of
Maybe.
those responses, and the reason why those patients were impaired at showing that adaptation is because without an amygdala for the DLPSD or whichever region to act on.
Yeah, it may be. I mean, I think, it might be, yeah. And I think, as you could probably tell, this is sort of a sketchy, this is our first stab at a neural model, right? But it's just a first stab, so.
Hi, thank you so much for such an informative talk. So my question, I'm really fascinated by this idea of cognitive control and shifting things and how you can make it more permanent. And one of the groups that we know has stronger cognitive control in general is meditators. So I have a two-part question. One is, has anybody looked at just the amount of implicit bias in meditators? And two, has anybody looked in a shift in bias with meditation in a group that does have implicit bias to begin with?
That I don't know of. I don't know of it, but there's some interesting work, and I'm trying to remember this study where meditators actually don't show better cognitive control in other types of domains. I'm trying to remember the study that I was just looking at. It was actually, I take it back, it was metacognition. It was a little different than cognitive control. But I don't know of anybody who's looked at meditators in this regard. So, I mean, people vary also in there whether it's something called motivation to control prejudice, right? So that has something to do with the extent to which we see the dorsal prefrontal cortex activity. So some people are not very motivated to control prejudice, and some people are. And Trish Devine, who's at University of Wisconsin-Madison, has looked at this as an important variable. So individuals who have a motivation to control prejudice are going to show much more engagement of dorsal prefrontal cortex when they're in following an interracial interaction than those without.
We're a bit over time, but let's take one more question. Vanna?
What's the effect of gender in all these assays in terms of, both sides?
Yep.
And in terms of different races, it seems like the white subject were clearly more biased in most cases. What happens when they see a different race?
Yep.
And what happens when a person from a different race has to make decisions about white and African American?
So, okay, first let me deal with gender. For the gender of the participant, doesn't make a difference. Now, every example I gave you was the faces we used were male faces. The only study done, and we do think the stereotypes about black males are different than the stereotypes about black females, right? And so the only study that I know of that used female faces was the one that I mentioned with the prepared learning. You don't see this effect, the prepared learning effect, if it's female faces. And so I would expect gender to make a difference in terms of the race of the stimulus. But in terms of the participants, it didn't matter if you're male or female. Now, what we know about implicit bias is if you're Asian American, you have a stronger pro-white bias than a pro-black bias. As I mentioned, if you're African American, you tend to be, as a group, neutral, but there's a lot of variability. So most of the studies I presented towards the end, the decision-making studies, we just had a mixed race group. And you could see bias went to the pro-white side and the pro-black side. And so we really were looking at relationships between these biases. Now, I think one of the things that, I think if you're looking at different groups, it's going to be a different neural system that you're going to see involved. I mean, the characteristics of cultural stereotypes vary for different groups. Some things are simply in-group, out-group, but some things depend on the nature of the stereotype, right? And so we're looking at a brain system that we think is involved in picking up threat associations. And so I think, we may not see the same thing if we're looking at gender bias, for instance. But again, you can see sort of patterns like this for all different types of biases in terms of decisions and things like that, but it may be more specific to what that bias, what that cultural stereotype is. And then, like I said, in terms of the other races, in the U.S., again, except for the African Americans, you generally see stronger pro-white biases from different race groups, not just white Americans.
Liz, thank you very much for a great talk. Thank you all for joining us.